sounds like you've had incredible experiences. So bringing this into the research that you're working on today, would you both dive a little bit more into the research that you're either currently conducted or have recently conducted in these extreme environments?
Sure. I'll start. I think for me, there's a part of adventure that drives my research inquiries. But I guess the big research questions that I'm interested in have to do with a specific type of ecosystems that are called peatlands. So they're wetlands that store huge amounts of carbon in their soil over thousands of years. And if you look historically at where these studies have been performed, it was mostly in Canada, Alaska, Europe, so northern places that are pretty flat. And so that's where I started my training as well. But eventually thinking about where else might peatlands be and what are the different locations potentially teaching us about a golden rule or, like a broader understanding of those ecosystems could be coming from understanding these systems that might be under more extreme conditions. And so we went all the way down to Antarctica to find some of the peatlands, and we described some of the first peatlands from Antarctica. All the way into Patagonia. And so there's a lot of, again, sometimes it's the research questions that helps guide where I go, but sometimes it's also where do I want to go, and maybe I'll find some peat there. And that's how Baker and I went to Peru, because there's some high elevation peatlands in the mountains that I thought would be amazing to go study and see how old are they, why is there peat there, how thick are they, how much carbon do they contain, all of those questions. So again, it's really a combination of really wanting to understand and document that ecosystem. And the reason why it matters is because these peatlands, they're about 3% of the land area, but they contain about a third of all of the soil carbon on Earth. So think about a forest versus its peatland soil, for example. The soils would contain 5 or 6 times more carbon than like a jungle. So super dense store of carbon. And they are kind of under threat by some of the ongoing environmental change and also land use change. So you're losing 3 times the rate of peatlands compared to the rate of forest right now. And we're trying to essentially monitor them, assess where they are, understand them so that we can help protect them.
Yeah. And how long have you been working on this peatland expedition of sorts?
I started as an undergrad, so in the early 2000s. And it was just a summer job. I didn't really know what I was getting myself into, but just like anything else, you start digging, literally, but also through the research questions, and you just want to know more. So it's been, 20-something years.
A lifetime.
A lifetime. Well, hopefully I'm not towards the end.
No, early stages of a lifetime.
Yes.
So the peatlands that you're exploring right now, you're uncovering, have three times as much carbon?
Oh, yeah, at least 5, 6. Yeah. Yeah, so they can be meters deep. Yeah.
So what can we learn in places like Nevada or other places in the United States from this information where we have this land with all of this carbon storage? How is it applicable to other areas?
Yeah, so a couple things. The first is that the peatlands themselves, those soils, you can think of them as layers, and the layers are like the pages of a book that you could read. So you can go at the base of the peatland, and let's say it's 10,000 years of age versus the surface would be today. So if we take the fossils that are contained in those layers, you can reconstruct the changes in climate that have happened in the past. And so we do that. And there's peatlands here in the Sierra Nevada that we're starting to core to do that kind of work. So it helps us understand when was it wet, when was it dry in the past, when were peatlands happy, healthy versus when did they collapse because of multi-decadal droughts. So it can help us understand the natural climate variability of a region and help us prepare for potential future changes that we might see. So that's one thing. And then the other about the carbon is really, if we know how much carbon is in the ground, then help us think about how much, how little we want to destroy those ecosystems, essentially. So if you have intensive grazing on some of these ecosystems, they stop acting as carbon sinks, and they could become carbon sources. So the carbon that was stored in the ground, and it took thousands of years, starts decaying and essentially being degraded by microbes and farted into the atmosphere as CO2 and methane, and is contributing to ongoing climate change. So I would just want to let them do their thing, those peatlands, and not destroy them. So it helps with land management and conservation.
Mm-hmm. That's incredible that information and research in Antarctica and Patagonia can help us here. It's a global issue, and you bring it home. That's wonderful. Thank you. Dr. Perry, you mentioned that you had some trips to Everest, so I'm sure that that's something that's ongoing, but could you as well dive a little deeper into the research that you're working on lately?
Yeah, so my current research focuses on understanding climate and climate change impacts in the highest mountains of the world, including on Mount Everest and also at the highest elevations of the Andes. And the major motivation for this is that these mountains serve as water towers. They store tremendous amounts of snow and ice that then melt sometimes slowly, sometimes not, and sustain communities downstream. And so I think there is a direct connection with Nevada and the mountains that we have here, and of course the critical role that snowmelt plays in sustaining communities downstream. And so I'm excited to really develop that more in my time here. But getting back to the big picture question, there are over 1 billion people that live downstream from these water towers in the Himalaya, Hindu Kush, Karakoram, what we call high mountain Asia, and also in the Andes. And before we went to Everest in 2019, there was only one weather station above 19,000 feet, even though that's where the bulk of the snow and ice outside the polar regions is found at those higher elevations. And so there was this huge void of understanding of just basic climatological processes, and also a big unknown as to how quickly key parameters such as precipitation, such as temperature, such as relative humidity, cloud cover, were changing up in the highest elevations. And so my work over the past decade, both in the Andes and in the Himalaya on Mount Everest, has been trying to fill that void and bring back the critical data that we need to understand what's happening at the highest elevations, just to improve basic scientific understanding, but also to improve the glacial-hydrological models that are used to make projections of future water resource availability in these locations. And so a lot of my role has been focused primarily on the installation and the maintenance and operation of the weather station networks that our teams have installed, and also just an analysis of the data that have come back from these. And so that has presented just a huge set of challenges, but also lots of opportunities to to get a glimpse into the roof of the world. I mean, before we went to Everest in 2019, we knew more about the weather on the surface of Mars than we did at the highest elevations in the Himalaya or on Mount Everest. So we've definitely learned a lot and have made some strides, but there are many other mountain ranges around the world that have huge data voids. And there are many places here in our own state of Nevada that have some big data gaps. In fact, we have the lowest density of precipitation gauges of any state in the country here in Nevada, and huge gaps on our higher mountains. And so that's a big priority for me moving forward, is to expand our observational networks and enhance some of the existing instrumentation that we have.
So I won't use the word lifetime again, but this sounds like an incredible process of research. So how did you get interested in these high alpine weather data conducting sort of expeditions?
Yes, that goes back to my childhood. I spent some very formative years living in New England in the state of Maine, and had some very severe winters there that I think captivated me with cold and snow and extreme environments. I followed the weather very closely from the summit of Mount Washington, which is one of the most extreme environments on the planet that's actually instrumented. And then when I was 7, our family moved to 13,000 feet in Bolivia, and I've lived there for 2.5 years. Went to school there. We took family outings up to over 17,000 feet. And I gained this tremendous fascination, but also appreciation for the role of mountains as water towers and sustaining communities downstream, and also, of course, the just rich cultural um, landscape of the region and the very significant indigenous cultures and traditions that were there. So that, I mean, that laid the foundation for me. And then I think as I returned back to our family's roots in North Carolina, I mean, anytime snow was in the forecast, I was camping out in my front yard. People, my family and my friends thought I was a little strange, and was just very interested in weather. And then as I went through graduate school and in my formal academic studies, I was able to find a way to combine these different interests with mountains and the highest elevations. And so that's kind of the pathway I took. A little bit circuitous, but the childhood experiences were incredibly formative.